get going here. All right, I'm Bill Kennedy. I'm not good with introductions, but I've been around for about there's Anthony. I've been around for about since 2013, um, writing books and blog posts, and I primarily focus on training, workshops at conferences, things like that. And what I'm going to do tonight is about an hour of the Ultimate Go software design class with Kubernetes, and focus on something that I've been really trying to study, not just theoretically, but actually in production. Something I'm calling domain-driven, data-oriented design. So there's almost at every conference lately and all over the place, everybody's talking about domain-driven design, and everybody's got a different twist to it. I'd argue that I do too. But I'm going to share with you sort of the architectural ideas, show a tiny bit of implementation here. And if it's something that you're really interested in, I've got video classes on this entire code base. This is what I'm doing. And this is the code base I use if I'm starting a new project as well. So let's just kind of jump into that. Let me start by, there we go here. And if anything's not big enough, just let me know. This is the coolest plugin I ever found for VS Code. And the reason it's cool is because it gives me my whiteboard. Oh, I love this thing. So I'm getting better and better using it as well. So really cool. If you know me old school, I used to put whiteboards up on stages because I need a whiteboard, but this is pretty good. All right. So in the class, this is really usually like almost the second to last day that we kind of get to finally talk about this stuff. Domain-driven, data-oriented design. All right, so let me just step back before we get too technical and just lay out some ideas here that I think are important. I think that whatever you're building in terms of software, you have to kind of understand a couple of things. So if I'm building something and it's just for myself, and it is something maybe I'm going to put in production, but nobody else is ever really going to work on it, it's more of a personal project, then some of these ideas I'm going to share tonight are overkill, unnecessary, okay? Because when we start talking about domain-driven aspects of architecture, we're adding complexity. Question is, why are we adding complexity? And for me, the only reason to add complexity in an architecture is because we're going to have a team of people working on it. We're going to have a team of people that are changing over time. And we've got to be able to make sure that we're maintaining some level of developer productivity. In other words, everything I just mentioned is really not necessarily a technical problem. It's a people problem. All right. And so some of the ideas that I'm going to introduce tonight add complexity because we've got people problems that we need to solve. My biggest one is this idea that if somebody else cannot come in and maintain the code that you're writing, that code gets thrown out the day you leave. And for me, the worst thing that you could ever say to, if you want to be utterly and horrifically mean to a software developer, just say this to them. I hope by the time you retire, not a single line of code you've ever written is running anywhere on the planet. Think about how horrific that is. Think about all the events that you've missed. Think about all the late nights that you've had, all because you had to finish some piece of code. And now that code no longer serves any purpose. And you start to think back like, my God, why did I like lose out on these things? And so I promise you this is going to happen if your focus isn't as a priority. How do I write code that other people can maintain? And the answer behind that is about wrangling complexity, reducing complexity, focusing on where that complexity is and doing your best to try to minimize it. Now, there was a great quote. Oh God, I can't remember his name. He's in the gaming space. And he said, You can't make something complex simpler, but you for sure can make something complex much more complex, right? And so I'm not sitting here saying that you aren't working on really tough, complex problems that you can just, no, that's not what I'm saying. I'm saying you are going to be working on complex problems, but you can always make them more complex if you're not really gauging what you're doing. And so the architecture, there's three aspects of this architecture I'm going to share with you tonight. Two of them I think need to be in every project, whether it's just you or a team. And that's the data-oriented aspects of this. The data-oriented architecture aspects you need to have regardless. The domain-driven piece, I think, is necessary for that latter part that I've already been sharing. So I'm going to introduce all of this to you as we go. And again, this isn't just theory like I see in a lot of talks. There's an actual implementation of all of this. This is code that's running in production for a couple of clients. And again, if I get hired to do something new, this is where we're starting. Okay, so let's start. Back in the year 2000, 10 years before Go is even being announced by Rob Pike, Grace Murr, and Ken Thompson, Brian Kernighan is asked this question in an interview. If you don't know who Brian Kernighan is, it's cool. Look him up. He worked at Bell Labs with all those three guys that I mentioned from the Go team. They're all friends. They know each other. And I'm almost positive when you look up Brian Kernighan's name, you'll be like, oh, yeah, I've seen it. So Brian Kernighan has asked this question. I'm paraphrasing everything here, by the way. If you want the actual quotes, I can give them to you. I'm just going to paraphrase. Brian, what do you think is one of the biggest shortcomings of the C programming language? Super interesting question. And if any of you have ever coded in C, your wheels are churning already going, oh, what do you think the answer is going to be to this one here? All right, what do you think is one of the biggest shortcomings of the C programming language? So paraphrasing, here's Brian's answer. I think one of the biggest shortcomings of the C programming language is that it doesn't provide enough mechanisms to create firewalls between the different parts of your program. And it's not that you can't simulate this. You could simulate OOP or whatever you want. The problem is that the language in the compiler isn't there to enforce it or to help you. When I read that, I fell out of my seat. I couldn't believe what I was reading. Because if you've worked in Go long enough, one of the very first challenges you have is the concept of packaging. What is packaging doing in Go? Packaging is the answer to Brian's problem. Packaging creates firewalls between the different parts of your program, and it's enforced by the compiler because every folder represents essentially a library, a static library, an API, and that's enforced all the way down to the compiler building that static library and then linking all these things together. One of the very first things that you got to wrap your head around is that your code base, this code base, is not a monolithic code base anymore, like you had in Java and C# and all the other languages that you were working with. This is no longer a monolithic code base. This is a code base of packages, a code base of firewalls, separating the different parts of your program. And it's a really difficult sort of concept to grasp when you're first starting because you haven't been trained to write software like this. But once you finally wrap your head around it, start to appreciate the need for these sort of firewalls between the different parts of your program. And so in the class, I will spend a lot of time talking about type systems and package-oriented design. And we go into these details because you have to really understand sort of the packaging mechanics as a layer of sort of firewall within the scope of your program. Now, we're going to get all that from the language, and that's one of them. I said these are there are two things that you've got to have regardless of how big the project is and how many people are working on it. That's one. We got to have a full understanding of package-oriented design. We have that. We don't have time in this talk to go any deeper there. So what's the second thing? For me, it's the layering of your project. You gotta have layers, and layers that have clear purpose, right? Clear purpose, and layers where you can have clear policy. Now, there have been studies throughout the decades, and I've got access to two of them. And essentially, both of these studies try to identify how many things can the average person keep in their head at any given time. Interesting sort of studies. And both studies essentially came to the same conclusion. And that answer is 5. That the average person can keep about 5 things in their head at any given time. Now, designing an architecture around a code base also comes with it this idea of wanting to be able to maintain a mental model of the code base, knowing where everything is, knowing the workflows, knowing. So if there's a bug or a problem happening, your brain can almost immediately identify where in the code base that is probably going on. The logs should help you get a little closer to that. So the layering has to be a big part of being able to develop your mental models. And I want to apply this rule of 5, which is we never want to do anything in terms of architecture that's going to require somebody to have to put more than 5 things in their head at any given time to understand what's going on. I call this the rule of 5. And you'll see that throughout this project. Now, in this project, at the outermost root of the project itself, let me see if I can make this a little bigger here. I don't know why that's happening, but all right, whatever. You'll see essentially 5 layers here. But for our purposes tonight, there's really only 3 layers of code here. We've got our application layer. Let's write that up here. So we've got our app layer of code. The next layer is, I call business. Now, the third layer you see here is called foundation. It's the foundational layer of packages. It essentially represents the, I call it the standard library for the project itself. So from an architectural standpoint, you've got your application level code and packages, your business level code and packages, your foundational level code and packages. But from an architecture, the third layer that I really want to talk about, I'm going to call the storage layer. All right. So you got your app layer, you're going to have your business layer, and you're going to have your storage layer. 3. When you could do things in 3, you're making things simpler. You're reducing complexity. I promise you that. When people show me some of their architectures, you know what? One of the first things I start doing is I start counting. I look at the root and I see how many folders am I dealing with just from the beginning. I see more than 5, I start to cry. When I go into a layer, I look, I got 3 layers in here. All right, I never have any layers in a foundational, because to me, it's the standard library. I got 3 layers here. If I open that up and I see 10 more layers, I cry. Because I already know my brain can't handle that. More than 5, it's almost impossible for the average person to deal with it. Okay, app business storage, app business storage. So let's talk about the app layer and what the responsibility of the app layer is. For me, every program, actually, it's a good question. I want you to think about any line of code you've ever written. Think about any line of code you've ever written in your life. I don't even care what the programming language is. I promise you that line of code can only do one of 3 things. It can either allocate some memory, read that memory, or write to that memory. That's it. Can't do anything more than that. That is what every line of code that you're writing does. It does one of those 3 things. Now, you want to take that to the next level and really make your brain explode? That code is only allocating, reading, and writing numbers. Numbers, that's it. Integers or floats, that's it. And we're on a Zoom and we can see each other and I'm doing things. And it's all because we're reading and writing numbers everywhere on the planet. Wild. Okay. When we talk about integrity at that level, what we're really trying to say is every one of those allocations, every one of those reads, and every one of those writes have to be accurate, consistent, and efficient. If not, you don't have integrity. All right, that's real low level. Let's step it up a little bit. I want you to think about any program you've ever written, any program you've ever written in your life. I promise you that it's only really doing one thing. Every program is essentially doing data transformations. There is some input, you're transforming that input, and you're producing some change in that input to what we call the output. It's a data transformation. We're all data scientists, whether we use fancy AI ML models or not. We all do data science at the end of the day. This is why when I talk about architecture here, at least in Go, I'm talking about data-oriented architectures, because it's all about that. Now, the job of the app layer for me, and by the way, this isn't the only architecture that can work. These aren't the only ideas that could work. These aren't the only policies that could work. I'm sharing with you what's been working with me. Now, at the app layer, for me, the responsibility of the app layer is application startup and shutdown. But if we want to focus on data, the job is to receive that external input, validate that input, call into the business layer, and then after the business layer is done, formulate some response, right? Do the data transformation for the response. That's the job of the app layer. Shouldn't be doing anything more than that. Receive, validate, business layer, back, out, done. We're good. We want to focus the app layer just on that. The job of the business layer is just that. It is to process the business rules related to whatever the problem domain is that we're trying to solve. And then the job of the storage layer, if we have a storage layer, is to make sure that that data gets persisted and it can be retrieved. So for me, we need these three layers of architecture, and they really need to be separated from each other. Now, I want to have a conversation with you about trust. For the longest time, and I mean for probably 2 decades, I had a design philosophy that said that no layer should trust the layer above it with performing proper data validation. Because essentially, we can't trust that layers are actually calling into each other in the right order, in the right sort of things. We don't trust anybody. So we're not going to trust data validation, because bad data in, bad data out. Now, over the last 5 years, I would say, changed my mind on this extensively. But I want to share with you why. And then I want to share with you this idea of, can we build instead of having no trust in any layer, building a trust system while still being able to get a guarantee that data validation is happening. It's easy for me to say that, you know what, I'm just going to trust Anthony blindly. And Anthony, you're going to give me data, and I just trust you blindly. I want to trust Anthony, but at the same time, I have to have some ability to at least validate or force Anthony to do validation before he gives me any data. That would be the same with anybody here, right? And there's techniques to do that, but let's start with why you can't have a no trust system to begin with. So imagine we're making some API call and a piece of data comes into the system. Now, I told you the app layer's job is to validate that this data is clean in order to execute any of these business rules that we want to execute against it. Now, forgetting about the mechanics of how you could do this, let's say that part of the data validation is a hit to the database. Maybe this is an update. Maybe this is a delete sort of operation. And we want to validate that this user does exist. Maybe we want to do an update. We want to validate the user exists. Maybe it's a delete. We decide we want to do this validation. The only way to validate that is to hit the database. So there's some mechanic to do that, and the app layer does it. And the app layer then finalizes its sort of validation. So now the app layer is free to call into the business layer. But the business layer right now says what? Oh, I don't trust you. I mean, you said you did, but I don't trust you. I'm going to do it myself because data integrity is way too important for me. So what happens then? The business layer has to make that same call because it's the only way to validate that this entity exists. And it does its thing. And then, oh my goodness, this business layer API calls another business layer API. And this business API also says what? I don't trust anybody. And what does it do? It goes in and hits the database. Finally, we get into the storage layer. And the storage layer says what? Well, I don't trust anybody for anything that they did. So it goes ahead, it hits the database again to validate everything. And then finally, it can store everything back, let's just say in the database. This is one request. And we've hit the database 5 times. And at our desk, this works great. And with 10,000 users in the system, fine. But we all know today that day one, you're almost going to have 1 million people hitting this thing. And so we might have super data integrity here, but the inefficiency is going to kill us. We just can't have it. What we need is a way of building trust in the system. So as this data is flowing, this is what we get with the same level of guarantee that we've got the data integrity. So how do we do that? How do we create a system of trust with, I'm going to call it the verify. In other words, for me, it's not even verified. What I want is the compiler to get involved. We have a programming language that has a compiler. Anytime we're writing code that allows that basically walks away from the compiler being able to do a check at compile time, we're putting ourselves in a situation where that bug can find itself in production. One of the things I always want you to think about is, and this can happen really easy with abstractions, is are we doing something right now where the compiler cannot give us this guarantee that we've got integrity in the code? There are times where, look, what you're trying to do, it is what it is. But a lot of times we don't have to walk away from that. And that's what we're going to do here. I want to get the compiler involved. Now, let me give you a few mechanics around how we do this in the code base. And the way we do this, and there's other reasons for doing this, but every layer needs to have its own data model to start. So that's rule number 1. Every layer has its own data model. And these data models are not really going to be duplicates of each other, as I'm going to show you. I saw a tweet this week for a friend of mine who's big into the event modeling world. And one of his arguments is you end up with duplicate data models here. And my argument is not really, but these data models are what's protecting your data integrity. And so I don't know why we'd want to walk away from it. Plus, remember, the app layer is receiving external input and sending external output. The last thing we want is the app layer to be moving this data around. That's not necessarily data that should be going in and out of the system. This is. So let's look at a data model sort of path here. And then I think that will better show you what I mean about how we get the compiler involved in order to give us the data integrity. So let's just look at a user for a second. This is a user in this system, all right? I'm trying, oh, finally it worked. Here's a user in the system. The app layer models have the prefix of app on them. And a couple of things here I want you to look at as it relates to this app layer model. One, the only types we're using are the scalar types, the built-in types, strings, bools, and ints, and bytes. Now, why are we doing that? Well, you could already tell that we're already saying at this app layer that the data that we're working with is what? It's based in JSON. And this is the type system essentially for JSON. And so what we're saying here is that we're going to accept JSON data in its raw format. Now, that really requires us to make sure we're doing proper data integrity as we move the data to each layer. But I want you to look at this data model. We're going to see the same fields. We're going to have these tags, but we've got a type system that matches the data that's coming in and out of the app layer. Now, let's take a look at the model at the business layer. Here it is right here. Now, notice a couple things right out of the box. One, there's no tags. There should never be tags in the business layer. The business layer is neutral. The business layer doesn't care where data is coming and going from and doesn't care about storage. It says this is the data that we're operating against. No tags. If I see a tagging system at the business layer, I would question it. Now, what else do you see here? Notice that the ID is based on a different type, but not a built-in type. It's a UUID. Email's an address, role, time. So what does that tell you? What does that tell you when you see that? This is what it tells me. It tells me that the business layer is communicating to the app layer that an ID can't just be anything. An ID just can't be anything. This is saying that an ID can be anything. There's no rules around what an ID. It's just a string. It could be anything. But the business layer is saying, no, can't just be anything. It's got to be a UUID. It's saying that the name could be anything, but an email just can't be anything. These can be anything. Well, bool is true or false, but these can't be, and neither can role. So I want you to think about this for a second. If the data coming in looks like this, and in order to make a business call, the data has to be transformed into this, we're now getting the compiler involved. Because essentially the app layer will be forced to parse IDs from a string into a UUID at the app layer, probably using a UUID parse function. Same thing with email, mail.parse. Same thing with time dot parse. Parse is the key. The parse function for a given type is what drives and validates and guarantees that Anthony is giving me data integrity. Because if he doesn't call parse, he's not constructing a user. And if he doesn't construct a user, he's not making a business call. And if that parse function fails at the app layer, well, guess what? The user's getting back an error that they didn't give us a proper UUID. The type system is everything here. The type system is everything. Now, these are types that come from the standard library, but I wanted essentially a set of roles that couldn't just be anything, while still getting a guarantee at the compiler level that somebody couldn't give me a role that wasn't valid. I'm going to show you a pattern that I use anytime I have a field that can't be anything. It could be name too. Imagine we've decided that a name can't be anything. If we wanted to apply some rules to a name, it has to be at least 3 characters long. It always has to start with a capital letter. It's got a blah, blah, blah. Then I would need a type called user.name with a parse function that would take a string and apply those rules. So the type and the parse is what gives us the guarantee that if this data can be transformed into this data, there must be data integrity. There must be. Now we don't have all the inefficiencies of that. And you're saying, well, Bill, we're doing marshaling. That marshaling is 10,000 times cheaper than that database call all day. And the data integrity is worth more than anything. You know, Go is a language that puts that first, right? It puts integrity first over performance. You want integrity? It costs you performance. I'll give you a simple example: 0 value. You cannot allocate any memory in Go that doesn't get initialized. You've got to run electrons through the machine to set those bits to 0. I'm sorry, and you can't stop that. So Go is already costing you some CPU cycles for integrity. I'm telling you, take that cost all day, right? Especially here, because it's going to save us in the long run. Okay, let's take a look at role, because this is the pattern, whether it's a set like role is, or a name, which might just be a regex or something else. Now, I've seen other talks that talk at some level about this. And then they get into this part of the conversation and they make a big, big mistake. So here's the mistake that I see before we look at any other code. They'll define a role like this. The moment you use an underlying type, you've walked away from compiler protections. Now, why is that? It's because of the way constants work in Go, essentially. So look, let's say I had a function named Bill, and I decided that Bill only is to take a role. You're thinking, oh, that's great. Compiler's gonna protect me here because the compiler's only gonna let me pass a role. Except the problem is that this is a string, it's the underlying type. And so the compiler will let me do this all day, because the compiler will allow the implicit conversion of this string into a role because of the way this is declared. There is no compiler protection with this mechanic whatsoever. So you can't do this. You just can't. Don't give me the argument that it's easier. You can't do something simple if it doesn't give you the integrity that we need. Okay? You just can't. You can't make that choice. This is what people have told me, and I want to cry. Can't make that choice. So this is what we're going to do instead. We're going to use a struct. And the struct can have a single field that is unexported. I don't care what you call it, name, value, whatever it is. I'm calling it name. Because once you do that, this will never work. You can no longer have this string get implicitly converted into a struct. We get the compiler protection now, all right? So that's rule number one, that we're going to use a struct to define whatever type it is we need for this data integrity. The next step is to have a parse function that takes, in this case, a string, returns a role, performs some data validation logic. Now, in our case, I wanted a set of specific roles. And so this is what I do right here. I define a set of exported variables. We do exported variables like this for error variables. This is fine. And then I define an unexported map with that set. Now, people sometimes say, oh, why are you using a map? Why don't you just use a switch case? Remember, the map is like 01, first of all. And this code is a lot simpler. And if we add new things, we don't have to deal with it again. If your Go program isn't as fast as it otherwise could be, it's not this map. Let's just start there. Okay. Well, Bill, these are exported variables. Somebody could change those. Well, guess what? If somebody's changing them, they get what they deserve. You should have better things to do than to be changing these variables. Same thing with your error variables, right? So I don't play on that logic. Now, one of you might see what I would consider to be the only real flaw here. And that is that you can construct an empty role. You could have a zero value based role. There's no way to stop that. But that's it, man. That's all you got. But you're going to be calling parse anyway. So we really walk away from that. And so to me, this is the key. If I wanted to suddenly have rules around name, I would write a name.go. I would write type name, struct, name, string. I'd write a parse function, and we're good. And now we get enforced by the compiler data integrity from app layer to business layer. And it doesn't stop there, because the storage layer, well, it needs models too. Look at this model. Look, DB tags. Why? Because in order to store and retrieve out of this Postgres, we need to define what those field names are. There's tags here. Look at the type system. We can't use, in this case, our slice. We've got to use This is another reason to have these models. Gives you the flexibility to use the right type system at each layer. And again, if there's a conversion that needs to take place, it forces the layer above to call parse and give you the right data integrity below. Okay, so regardless if it's just you and your own project and these things, package-oriented design, can't get into the mechanics of, and then layering is critically important here. I think you only need these 3 layers. I really do. These layers serve clear purpose. You can have layers inside of layers, as you saw, but we can identify very quickly, what do we need? We need a package. What is its purpose? Its purpose is this. Then it belongs in this layer. And then it defines those policies. These layers define policies, what they can do. But now you only have to worry about these 3 data models of integrity, and it's something you can absolutely maintain and manage in your head. Okay. Now, if it's just a project, there's a project I'm working on right now as a personal project, and that's it. This is all I'm doing in that project. I got my package-oriented design, I've got my 3 layers, and I'm keeping it simple. It's beautiful. But if I'm working on a team of 3 or 4 people, and I know that this code is going to have to be delivered to another team, or I'm going to have people coming in and out, to me, that's not enough. You need another layer of firewalling here. And this is where the domain-driven stuff comes in. All right. The idea of the domain is to create a third firewall. Again, not to solve some technical problem, because we're about to add complexity. It's to solve a human resource problem, a programmer problem, okay, in that sense. So let me share with you now how the domain-driven side comes in when you need it. So here's the idea. We look at the data that we're going to be managing in this application. In this particular case, if I look at the different core packages that we have, and again, in a class, we'd be building up to this, but in this product here that we've got, there's basically 3 core business packages or domains of data that we're managing: homes, products, and users. And it could get this granular if you wanted to. The more granular, maybe the more flexibility you have for larger teams. Smaller teams maybe don't need to be as granular. But home, products, and users. So what we can start off with is this idea that, okay, there's user data that we have to manage. There is product data that we've got to manage. And there's homes that we have to manage. And I would say start granular first, and you can always join things. It's easier to bring things together than to split them apart. It just is. So here's the idea now. Let's say we're going to start off initially, but this is the three domains of data that we're going to need to manage. And so the idea is, let's create another set of firewalls. But what these firewalls do is create these vertical silos. All right. So packaging is at the lowest level of our firewalling. You saw the type system play a big part in that. The horizontal firewalling is those layers of code and responsibility. And now we draw these vertical lines, which represent the different domains of data. And the idea is that a developer should be able to work within the scope of these 3 layers in this domain without stepping on another developer who's working in here, without stepping on another developer who's working in here. Now, there are many companies, especially early in the last 10 years, that decided that these vertical lines represented different services, right? That's where microservices sort of comes in. I don't want to do microservices. I don't want to have to manage and deploy multiple services. I want to manage and deploy one service. And I can grow that either vertically or horizontally. And so the idea is that these domains, again, can almost be treated like microservices in the sense that We're going to isolate the code and the people that work on that code from the people that work on this code, with it all still being in a single project, being built and deployed together. Okay, and that reduces a bunch of complexity. Because in this world, these different domains do need to talk to each other. This isn't going to be stateless sort of microservices. And then that point, you need the gRPC, you need this, and okay. So let me play this out a little bit here, because this really looks great on paper, and this can also get incredibly complicated depending on how pure you want to be in its implementation. And again, I'm always about minimizing and reducing complexity everywhere I can. So imagine this scenario here, right? We're going to do something with a user. It comes in here. Now the app layer does its data validation. We already learned how to do that. And then what it does is it makes some sort of package call with that data into the business layer. Then it's going to do its business rules. It makes another package call into the storage layer. And then the idea is, and just go with me for a second here, okay? Just imagine this potential situation here. There's nothing, if this is a true silo that I'm talking about, a true firewall, then think about this. Couldn't, even in the same project, forget about that, couldn't this domain have its own database that it's storing its domain of data in? Absolutely. In fact, in order for this to work, we've got to maintain that belief system. Even if we're not doing it, we have to, at some level, maintain and do things so this is true. Now, what does that mean? That would mean that we would have the same situation for anything going on here, same situation for anything going on here. And when you really think about this, then couldn't this database be Postgres? Couldn't that be Mongo? Couldn't that be some sort of graph database? Keep that in your head as well. Not just believe at our architectural level. For me, this is our architectural level here, okay? This is where our architectural level ends. So for everything above this line, let's always believe that each domain has its own database and it is of some different type. Because if we believe that, then we know that data can't be joined across these domains. They truly exist within a clean and clear firewall. Okay, let's play some theoretical games with this architecture now, based on real world applications that we have to build. Because this works brilliantly well with CRUD, doesn't it? Add a user, modify a user, delete a user. I could stay in these lanes all day long and life is good. But let's get into some real world stuff. Let's say that we've got a front end, UI, browser based, and one of the screens is a screen that lets you look at all the products that are in the system. Obviously, there's going to be millions of products because we're just that big. And you're not going to be able to bring back a million products to the UI. You've got to page that stuff, don't you? So think about this, right? We're going to have some sort of query API that we're going to call, and we're going to say, give me the first 10 pages of products in the system. Okay, that's not a big deal, right? That has to go through this lane here. So we call the query handler, which calls the query function here, which calls into the query storage layer, hits the database, comes back out. And what does the front end end up getting? Well, let's just take a look here. We've got our handlers, our products, and our models. All right, there it is right there. So what did it get? It got this, right? That's what it got. See if I can trim that down. Good. All right, this is what it got. Here's the problem right here, user ID. So you know what the first thing the marketing team or whoever's using this front end says, right? Hey, Bill, it's great you gave me back this product, but I don't know who that user is. All you did is tell me that its user ID is gabba gabba good. I need to have the username. Well, that's really not a big deal, is it? Because think about what we can do. We start off with this query here, right? We go down, we come down here, and we go up. We come back up, and we now have a set of products. We have 10 of them. So we look at those 10, and we get the 10 unique IDs out of it. And then what can we do? Well, we could do the only thing that we can do. What do? Because we're in a single project, this doesn't have to be a gRPC call. This could be a API call directly to that business package. Now, why do we get to make this call? Because the data says that we have referential integrity with the user domain. We have a user ID. If this domain has a user ID, it's allowed to make calls into the user business packages. In fact, home has a user ID as well. Home also has products. So you can see that we can get away from these ideas of cyclic imports by just looking at the data. Okay, so this is no big deal. We go first here, and then we go here, and then we have a model that is like maybe app product details, where what we do is we add the username or something, right? In capital world, username, you get it. And now they get the username. And we've stayed in our lanes, and we've done what we're supposed to do. This works. Yeah, we haven't destroyed any of our domain-driven sort of rules here. But you know what's happening next, right? They love this. You're so grateful. But now they say, well, Bill, this is good, but I've got to be able to sort and or filter on username. We got a big problem now. Because remember, sorting especially has to happen down here. We can't be sorting up here because we'd have to bring back all million products, cache that in memory, sort it, get whatever page, and send it. Ain't gonna happen. Not on my watch. Sorting has to happen here. And the problem is that username doesn't exist in this database. And remember, from our perspective, these are all different. Now, can we go back to the client and say, sorry, you can't sort and filter by username? I mean, you could. You ain't going to be working much longer, but you could. So let's not do that. Here's where things start to get fun. How do you maintain our domain-driven firewalls, not allowing the joining of data in the storage layer because you can't, because this data has to stay in its lanes, yet still supports something like I described? What's the answer to this? Again, I'm adding complexity, but why am I doing it? Because if I keep these lanes, I can put developers in these lanes. And a lot of these types of systems we're talking about also come with a large number of reports. Reports are classic places for joining data across domains. You can get real ugly really quickly. Now, you might just say, I'm going to start cheating, Bill. I'm going to cheat in the storage layer, but I'm going to tell you, always constantly believe that we've got different databases here. Okay, but we know we can't. So I want to solve this problem. How do I solve the filtering sorting problem while not breaking any of my architecture up here? And breaking architecture would mean that I'm allowing a SQL query to cross domain on those tables. So we're going to do the first thing here. And I want to do this because if we don't break our architecture here, later on, we could do this if we wanted to, when we need it, if we ever need it. So let's do this first. Let's start by agreeing that we're going to have a single database. However, let's agree that inside of our single database, maybe it's Postgres, that we're going to maintain our domain level sort of silos in here. Now, there's two ways you can do this. We could decide that any table related to the user domain, why can't I do this? Starts with a user prefix, right? Or a prod. We could do that. Or if you have a database like Postgres, you could do that with schemas, couldn't you? It says to find a schema for the user domain, a schema for prods, the schemas for, you can do it either way. I've done it like this, and it's been fine. It's been fine. Okay. Well, Bill, still not solving this problem here where I've got to filter and sort. We can solve it now. Why? Because in order to solve this problem, I need data that has not just everything that's product, but also has that username in it. I need a new table. I need a new database or a new table that has that data in it. Ideally, what I want to do for this problem is create a new domain, right? Whatever I'm going to call it. I want to create a new domain with the idea that this domain is separate from the others. And in the case of what we're talking about here, the query that now has to drive this paging of products with filtering and sorting by usernames comes down this pipeline here, right? And would also be able to access this database. However, I told you that no matter what, you still cannot be doing joins here. So what do? What we're going to do is what I call leveraging 40 years of database technology. I'm running on a Postgres SQL server right now. So what can I do? Now, I could make this super complicated on myself. Think about it. This is what I would argue a purist would tell you. Well, Bill, what we're going to need here is a table. A table that is everything that's products plus the username. Yep, we know that. How are we going to populate that? The purist would say, oh, Bill, this is not a problem. We're going to overlay an event system, you see? And what's going to happen, Bill, is that when a new product, right, call comes in, well, it's going to write it to its database, and then it's going to fire an event that's going to get. And then that's going to go, and it's going to go then and come back over here, get the username, and then it's going to come in and write that record. We could do that. And if we truly, and I mean absolutely truly needed separate databases here, this is a solution. But does your brain hurt? Because my brain hurts. I mean, we just added a good amount of complexity. And if you're going to do this event asynchronously, well, now you just 10x that, okay? 10x it. Because what happens if the event doesn't fire? What happens if there's a delay? How are you going to debug that? How are you going to know what's going on? I don't want to live in that world. Well, Bill, what are you talking about? We're going to drop NATS in there, and NATS has persistence, Bill. And don't worry, it's never going to get lost. And I'm like, I like to sleep at night. And so, yeah, no, not while I'm here. So then how can we do this? How can I eliminate all that complexity and still get my table? What do SQL servers have? at least Postgres and everything I've worked at since the 90s. Boom. Think about it. That's right. Views. Let the database do the joining for us in the database layer. This maintains our architecture because now this is going to do a straight query to just that view. No joins here. The joining is happening underneath the architecture. This can happen in any way, right? If we even wanted to break up the database, I would argue that this data doesn't come from this system here. It comes from something below it. Move that complexity out. Keep this clean. But a view here allows us to maintain our vertical firewalls or domains without breaking these sort of architectures. And we can create all the views we want all day. And when a new report comes in that's really insanely crazy, we don't break this, we don't touch this, we don't touch this, we don't touch this. We had another domain, and we're not touching and breaking anything that we know that works. Now, you might say, well, Bill, you could end up with 30 of these domains. You might if you can't reuse a view for multiple reports. Yes, every unique view will come with its own domain. But I've been on projects already with this architecture where we're behind because management's decided they want 5 more reports. And I'm like, give me 2 more bodies. And I can throw them now at this problem because the Go code here is fairly now boilerplate. The big work is generating the view. And these developers are working in their own sort of silos, and we're building the system out fast. And I don't have to worry about any of this breaking because we're not touching it. All right. Pretty cool. And another nice thing, I think, again, is if you do the database stuff below the architecture, again, there can't be a queries here. When I say your queries are here, but I better never see a prod table being touched. I better not see anything but prod being touched. I better not see anything but that view being touched. I'd catch that in a code review. But here's the other thing. And I feel like this has been lost somewhere along the lines. And it was a big part of my job in the 90s. At some point, your database becomes super inefficient. If you're lucky, you have a system that's heavy write. And that means that you optimize your indexes and things for writes. Or you might have a system that's heavy read, which means you want to optimize indexes for read. The worst thing in the world is when you have a blended sort of, I'm heavy read and write. Now the world comes to an end on you. And so I think one of the other nice things I like about the architecture is that it gives us the ability to do things like this, where we could use maybe, again, 30 years of database technology, things like this, where these tables in this database are indexed for transaction. And then these tables here, these views are indexed for read. And again, the data replication is all happening, say, below the architecture. We move that complexity down here. So this to me is what I mean about data-driven, domain-driven, data-oriented architectures. And all of this that I'm sharing with you, though I'm using a single database right now with views, is fully implemented here across these 3 domains: homes, products, and users. User summary is that blended model sort of domain that's using a view in order to do that work. And this is code that you could even now review and kind of look at, from the app layer models to the business layer models under core. And each core package has its own storage layer, because the idea is that only that domain should be accessing its own store. So we tuck it in there as that sort of relationship. So you have an actual, I would call, production implemented sort of implementation of this sort of domain. Now, I said start granular. There's nothing stopping you from deciding, I'm going to put these 3 pieces of data in a single domain, but then you're going to have the one core package. Just remember that, right? So those core packages represent a domain. I've had situations where a client said, Bill, we have another database and we haven't been able to build the REST API yet. So you need to talk to that database and do the same queries that we do in another system until we can get to the web API, which they never do. And so we've built an entire domain just for what? This third-party database that we have to do queries against and things like that. And so a lot of this also, as I always talk about, you're going to build this out. How does it feel? Is this right? If not, refactor. Is it right? Not refactor. The more code you add, the more it may start not feeling right. But for small projects that I'm just doing myself, I don't add this third level of firewall. I just don't. I might have core packages, but they're all, for the most part, at that point, I'm allowing for, you can never really allow for joins here, so I shouldn't say that. But I don't necessarily go crazy with the domain verticals when it's just me. I might have a single data package that's letting me do the queries that I need and sort of keep my architecture clean up here, and then sort of cheat down here when it's sort of my own simple projects. But if I was going to work with any of you on a project and we knew that this had to be maintained for longevity and not by us, I would never cheat down here, ever. I would cheat here, which is where I'm cheating. Right? A pure domain-driven person doesn't like me in this case. But you have to be practical. You gotta pick your battles. You gotta get this stuff done. You gotta get it working. Now, there is one scenario, if you give me 5 more minutes, that gets interesting here. And that is, I told you that the prod can talk to user because the data model has a user ID in it. But imagine this scenario real quick. Let's say we wanted to delete a user. All right. If we delete a user, what else should we delete? Well, that user's products, those users' homes. I mean, anything related to a user. But the delete call is coming through where? It's coming through here. And we've already established that the user domain is not allowed. No. Not allowed to, I don't know what I just did there. All right. Is not allowed to make a call into prod or homes because there's no data integrity in that, right? There's no foreign key. A user doesn't have a product ID. A user doesn't have a home. How do you do this? How do you solve this problem where the path of execution is coming through this domain, but this business layer has to execute, say, delete operations here? The only way to do this is now through an event system. But I'm going to tell you that that doesn't have to be asynchronous events. Let me show you a little bit of code. So we're in the business layer here, okay? We're in the user domain right here, event.go. Look at what we do. We have the user domain define an event, like in this case, user updated. And anytime a user gets updated, let's find the update. There it is. The update operation occurs at the store level, and then it executes the event. Now, let's look at product event. What is product event doing? It registered itself to receive on that execute call this function to get executed when a user is updated. The register, right? The register is essentially a map of function calls. Source, source and type, source and type, source and type. So source user type updated, you execute this function. But I want you to look at something. Do you see a go routine here? Nope. I would never want to add that complexity in my life. Never, never, ever, never, ever. Don't need to. But what this little package does is it basically allows this call to be an indirect function call across the domain. But we do it indirect as opposed to direct. Pretty cool, right? And so we're able to make these calls across the domains. We do it synchronously, but indirectly. No extra complexity of gRPC, no complexity of Go routines. It either works or it doesn't. And also, by allowing this to happen, at some point, we can even support transactions there. And by having a single database, this code base also now supports transactions, which you could never have if you want to go pure domain driven. If each domain is truly going to have its own database, and you've got operations like this indirect one or the other ones that go across domains, and you don't have transactions, it's bad. Like, we know it's bad, right? You can't have it. So one thing that drives you sometimes from having a single database, no matter what you want to do here, is because you need to initiate a transaction every once in a while because you're updating data across these sort of domains. But we can still do that in a very clean way. We can maintain our silos. And if you look at some of the transaction stuff in here later, you'll see that transactions get initiated at the app layer. So these calls can happen across domain. To me, it's like the beauty of almost microservices, but in a single code base. Gives you that productivity on the developer side to move quickly without breaking code you already have. And then your deployment is nice because it's all in one binary. And one other thing I did here that you can kind of play with a little bit is this idea that you can actually build different binaries with different route sets if you really wanted to go microservice sort of crazy with allowing the microservice to actually still be stateless. You could just say, build me a binary with just the CRUD APIs. Build me a binary with just the reporting APIs. And now, if you did that, then the binary you built with just the reporting APIs could be configured to just talk to this database, right? And then the binary you built with the CRUD APIs, well, they talk to that database. And you can still, at some level, have a sense of these microservices. But for me, and I've been successful in doing this, thank God, if I'm building a separate service, I don't want it talking to any other service, right? It's stateless, it stands alone, it does its thing, minimizes that complexity. I've been lucky to do that. And this architecture allows that too, when you're ready. Would I do that day one? Hell no. But at some point, you might be saying, these report APIs are killing us. We've got to offload them. Now it's as simple as saying, let's build a binary for just those routes. You're done. And you're going. Anyway, that's all I'm going to share with you tonight. There's a lot there. I've already talked for about an hour. It's what it takes me. My entire software design class is about this code base and giving you a full mental model of what we built. We write it again from scratch, pair programming, and explain everything we're doing, and most importantly, why. You don't have to agree with all these concepts, but what's great about this is it's a starter kit. You get to rip it apart and put it back together any way you want. And I just want to stress one more time. Domain-driven design is good when you have teams, especially teams of people moving in and out of a project. When you have tight deadlines and you want to build quickly, it adds a complexity, but it can give you the human performance when you need it. Do not do this unless you need it. Don't do anything unless you need it. Don't add complexity unless you need it, is always my biggest argument. And don't add complexity because you think you need it tomorrow, because tomorrow's not guaranteed. build what you need today, and you'll be better off for it. That's all I got. I really appreciate you all listening. It was a long hour, and I appreciate it. Thanks.
Yeah, thank you, Bill. I appreciate that. That was certainly interesting and engaging. Didn't realize it was an hour already, so that was good. Yeah. Appreciate that. Where can people continue following you and reach out after this? Like, I know you're probably very active on Twitter and other places, but do you want to give a
Yeah, Twitter is
spiel on that?
my Twitter's good. There I am going. So the first blog I ever wrote, when I decided back in 2013 to write a blog, I got the domain goinggo.net. And not knowing anything about social media, I didn't want to like give out personal information. I actually asked somebody if there was a book on Twitter, and they laughed at me at the time. I had no idea what I was doing. So I said, I'm going to come up with I'm just going to make my name goinggo.net after the blog. Sounds good, right? Well, like about 2 years, 3 years in, I decided I didn't want to do that anymore. And I wanted to use my name, but I had just printed a bunch of remember business cards? Nobody has them anymore. I had printed like 2,000 business cards, and it had goinggo.net on it. And I'm like, I'm not throwing these away, man. So, but the handle comes from, in fact, if you do that, it will redirect back to the Arden blog now today. So, so goinggo.net is good. But if you really want to make sure I don't lose anything you're doing, just send me an email to bill@ardenlabs.com, and you'll get a response within 24 hours. I'm pretty good. Even if my response says I can't get to this right now, but I promise. If you DM me on LinkedIn, it could take 2 months. Slack and Twitter could take a couple of days, depending on what I'm doing. Email, you'll get me almost right away. And this is, oh, I stopped sharing. Hold on a second. And this is the repo for that code base. And if you read the wiki on it, I've started, instead of writing another book, I started writing the book, but putting it into the wiki. So some of the things that I've shared a little bit, and this is some good reading. And there's some cool stuff in there already. I'll continue to add to that. But yeah, if you want to play with the project, you could literally just clone it. There's a make file, read some instructions there. You'll get it up and running pretty quickly. But the wiki is pretty cool there. You can check that out. And I'm sure my email is everywhere. I don't hide that. So you can always just email me. And if I don't have an answer, I probably know somebody who does, and I'll get you to the right person. So no problems.
Awesome. Thanks. Let's see. We got one more. Let me share here before we cut out. All right, awesome. Yeah, so again, thank you everybody who showed up today. It was a good turnout. I appreciate you all showing up. Just want to say, be on the lookout. I plan on sending out some kind of survey probably tomorrow, just to get some feedback on this session and about what you want to see in the future. I would really appreciate your response on that to help me know what to look out for, especially if you have recommendations for speakers and topics and things like that. Reminder to register for our next meetup in two weeks from tonight. And we also, if you're not aware of Gopher Slack, maybe you've never heard of it, Gopher Slack is a giant Slack community of Go developers with probably thousands of channels. So there's something for every significant package, framework, or concept out there, so you can find people to connect with and get support from. But we have a channel in there as well, Charlotte. So if you're not on it, join it and pop in and say hey.
You should change that link to gobridge.org. I think that one still works. So.
Okay, I think that's the link I found off of the.
Yeah, I think I have it working, but
okay.
Just use gobridge.org. And what was I going to say? And the GDN also, Wilkin has been putting together a list of speakers, so you can bother Wilkin at gobridge.org, and I think we've got some speakers and we've got conferences coming up already. So you'll have
Nice.
speakers that want to test their talks.
Yes.
It's always a good thing.
All right.
And then don't
Yeah,
forget to bother Paul on the Zoom links.
cool, will do, for sure. Well, thank you, everybody. Appreciate you being here, and that's it for this week.
Awesome. Thank you.
Yeah.
Thanks,
Thank
Bill.
you.
Thanks, Bill.
Got it.
Thank you.